Just for level purposes, if you would give me your name and title, please.
This is the Dominion Network of the Canadian Broadcorping Castration.
Hello, I'm Sue Nelson, and thanks for joining me on Create the Future, a podcast brought to you by the Queen Elizabeth Prize for Engineering. Vint Cerf has been Google's Vice President and Chief Internet Evangelist since 2005, but his achievements and fame predates and surpasses even those rather awesome titles. One of the so-called fathers of the Internet, he was among the winners of the inaugural Queen Elizabeth Prize for Engineering in 2013 for his work on the Internet and the World Wide Web. Thank you, Vint. Let's start with that rather amazing title. I can't let it pass. Chief Internet Evangelist. What does that mean?
Well, first of all, we're making it up as we go along. Second, I didn't ask for that title. In fact, when they asked me what title I wanted, I said Archduke. But Larry and Eric and Sergey went away and came back, and they said, the previous Archduke was Ferdinand, and he was assassinated in 1914, and it started World War I. Maybe that's a bad title to have. Why don't you be our chief internet evangelist? Now, I must correct one thing for you, and that is that my work was on the Internet, but Tim Berners-Lee is the one who invented the World Wide Web.
That the prize, though, sort of incorporated all of you, didn't it?
Yes, it did, but you were introducing me and not the other four people who received that honor in the...
All right, I said among the winners. Is that allowed? Among the winners?
I see. Yeah. I didn't hear that.
Okay. All right. So I'm okay then. Am I off the hook?
Okay, fair enough.
Yeah. So what does it involve? Do you go around being enthusiastic? Because you are quite an enthusiastic person and you're not averse to having a bit of fun.
Oh, of course not. I mean, what's life if you can't have fun with it? And I think a sense of humor, frankly, is essential for survival, especially in these days. So
that amazing title again, you go around enthusing?
Well, actually,
evangelizing?
It is evangelizing when people wonder if it's a religious title, and I tell them I'm geek orthodox. But the honest... The honest effort is to get more Internet built around the world. I mean, even now, as we speak in 2020, only slightly over 50% of the world is online right now, and I would like to get everybody the opportunity to be online. I don't want to force anyone online. And we have lots of reasons why people might resist going online for a number of concerns, which I hope we are talking about later. But it is essential to go around and get government's policy set in such a way that it will attract more Internet implementation. There has to be investment in infrastructure, transmission facilities, whether it's optical fiber or cable or radio, 4G and 5G and so on. All those things are needed in order to support Internet protocols and the transfer of data to support the World Wide Web. So I go around trying to convince lots of people, whether it's in the private sector or in the public sector or government, to adopt policies, plans, procedures, practices to help increase the accessibility of the Internet.
Now, somebody like myself who uses the Internet every single day, multiple times a day, it's a part of my life. What do you see as the benefits for the rest of the world who perhaps are approaching the Internet for the first time, other than, becoming obsessively checking social media or using it as a research tool?
Well, we could talk about whether that's a good thing or a bad thing. The good part is the enormous access to content of the Internet, which, of course, is quite varied. And so companies like mine at Google have as one of their primary objectives the ability to uncover for people best quality information we can find, which is why we index the billions of pages of the World Wide Web, and we try to rank order them when someone does a search to produce the best quality information matching what we believe they're looking for. So my view right now is that the Internet is an enormously useful tool, and some of the variations that Google has introduced include translation. So sometimes the information you're looking for is in a language that you don't speak. We can automatically translate from one language into your preferred one In my case, that would be English, but for other people, it might be French or German or Russian or Chinese or something else. And so we use artificial intelligence tools, primarily machine learning, in order to accomplish that objective. Keep in mind that we are indexing all content in all languages, and that, of course, is a huge benefit for people who are trying to find out answers to questions that they have. Of course, Google has added other applications as well, electronic mail being a very popular one, and more recently, the Google Cloud service, which is essentially computational services, so that companies and individuals who need the power of computing and they need it to expand it on demand go to companies like Google and others to get access to that capability so they can build their own applications, possibly for themselves and possibly as tools for other people to use. So there's this rich environment of computation and application that the Internet supports. And so from the beneficial point of view, it's a wide open space. I mean, it's almost as if software is an endless frontier. You can do almost anything you want to if you can figure out how to program it.
Now, you're a mathematician to begin with, a degree in maths, PhD in computer science, and yet the Queen Elizabeth Prize, actually, I think probably surprised a lot of people in that it made some, for the first time, think of the architecture of something we used every day as an engineering success.
Well, and indeed it is an engineering success. And I consider myself, although I am trained as a computer scientist, I like to build things, and I like people to use what I build. And so there's a synergy between the computer science side, which is the theory behind packet switching, which is what animates the basic Internet structure. And then there's the practical side, which is building something which is affordable, which is reliable, which is secure, which we have some work to do on, and which provides a platform on top of which new applications can be built. And so all of that takes serious engineering, especially when you think about it. It's global in scope. It has to work in every country in the world. It has to work in different languages. By good fortune, the parts that I was responsible for and my colleagues didn't worry too much about language because everything was in binary bits, zeros and ones. Language becomes something which is up in the application space, and my protocols, TCP and IP, don't know anything about that. It's other people like Sir Tim Berners-Lee, who's another one of the recipients of that inaugural prize, who did the application layer work that creates the World Wide Web.
So let's go into what you did, because I think people are familiar with IP, TCP perhaps not so much, but they're never entirely sure what it actually means, even when you actually explain what it stands for.
So, we should start with that. First of all, the Internet's architecture is a layered architecture. There are a series of different protocols layered on top of each other, the lower ones supporting the functionality of the upper ones. The second thing to realize is that concept arose out of an earlier network, which was built with the support of the Defense Advanced Research Projects Agency in the U.S. That was called the ARPANET, which stood for Advanced Research Projects Agency Network, surprisingly. And it had a component here in the UK. One of the nodes of the ARPANET was installed in July or so of 1973 at University College London in the laboratory of Professor Peter Kirstein. So sadly, Peter passed away at the age of 86 last January of this year, 2020, but had a long, long history of connection with networking, not only with the ARPANET, but also with the subsequent Internet. So the Internet protocol layer is easily understood if you know anything about if you know about postcards. Postcards. And you think about them as if they were electronic postcards for a moment. The Internet packets have a to address, a from address, and some content, which is similar to a postcard. The to address, of course, is where it's supposed to go. And when you think about what you do with a postcard in the postal world, you put it into a post box and you assume the post office will eventually deliver it to the destination, and you've no idea by what route it might go, and you don't care. You also know, however, that the post office is not 100% guaranteed. So sometimes if you put a postcard into the post box, it doesn't come out at all. This is also true of internet packets. You can put them into the internet. Sometimes they don't come back out again. These are called best effort systems. The second thing that you know is that if you put two postcards into the post box addressed to the same destination, there's no guarantee they come out in the same order you put them in. This is also true of internet packets. When you put two of them in, one after the other, to the same place, they may come out in the other order. The third thing that the internet does that the post office doesn't do sometimes is to duplicate packets. So if you put one packet into the system, two may come out the other end. The reason for that is that if one of them gets lost or appears to have been lost and gets retransmitted, it's possible that it didn't really get lost. It's just that one of the parties thought it was lost, so it sent a second copy to recover from that, and then two of them show up at the other end. So you might wonder, why would anybody want to use a system that loses things, gets them out of order, and possibly duplicates them? And the answer is because that's the simplest and easiest way to build this lowest layer of the architecture. In order to correct for all of those deficiencies, we put another layer of protocol on called transmission control protocol. And the best way to understand that is to imagine your task if you were sending a book to a friend through a postal service that only carried postcards. So you can't give them the book. What you can do is cut the pages out of the book, cut them up so they fit on the postcards, and then you realize that not all the pages have page numbers because you cut them up. So you literally write down numbers on each postcard, 1, 2, 3, 4, 5, 6, 7 in sequence, so that your friend, on receipt of the disorderly postcards, can put them back in order or can recognize that there's a missing postcard. So now you've got all these postcards that you've pasted the pages of the book on. Now you have the problem of remembering that they might get lost, so you keep copies in case you have to send duplicates. Then you wonder, how do I know whether my friend has gotten the postcards that I've sent? And so you had this brilliant idea that he should send you, or she should send you, a postcard saying, I got everything up to postcard number 420. Then you realize that postcard might get lost. So then you say, what do I do then? And the answer is, well, you look at your watch, and if you haven't heard anything from your friend for a while, you start sending duplicates until you finally do get a postcard telling you what the state of affairs is over on your friend's side. Then you start thinking about one other possibility. Suppose you had a 1,000-page book, and you cut it up into 2,000 postcards, and you took it down to the post office, and by a miracle, all 2,000 of the postcards get delivered to your friend's post box on the same day at the same time, except they don't fit because the post box only holds 200 postcards. So the other 1,800 blow away or the dog chews them up. So you decide, okay, I have to have a deal with my friend that I won't send more than 200 postcards at a time until I actually hear whether he or she got those 200 before I send the next batch. That's called flow control. That's how TCP works. It does the flow control, duplicate detection, retransmission, and reordering. So those two protocols create a uniform and sequenced stream of postcards going from the source to the destination, and then we build on top of that all the rest of the internet, including the World Wide Web.
That's amazing. I'm not sure I could repeat what you just said, but that made it understandable, but also made me realise how logical it was, and I can see why you'd need a mathematical, very logical brain to do each set.
Well, in fact, much of the design of the internet is a consequence of thinking logically about the constraints on the problem and then deriving solutions which were almost obvious as you understand the constraints that require you to do certain things to overcome deficiencies in the system.
Was this all while you were at DARPA, the US Department of Defense Advanced Research Projects Agency? What made you leave DARPA?
Well, I was at DARPA from 1976 to 1982. Prior to that, I was at Stanford University working on the internet design with my colleague Robert Kahn, who by that time had gone to ARPA himself from another company called Bolt, Beranek and Newman, which built the underlying packet switches of the ARPANET. So I had 4 years at Stanford. Then I came to ARPA for another 6 years. And in earlier incarnation, I was at UCLA working on my PhD, but also working on the ARPANET project. So I'd had quite a few years of working on this ARPA-sponsored network research. And around late 1982, I had two sons, and I started calculating how much it was going to cost for them to go to college, and concluded that I might not be able to do that on a government salary. And so I joined the private sector, specifically a company called MCI, where I was asked to help them build a digital post office, which we could easily translate into an email service, but it was a commercial email service. And it was called MCI Mail. So I went to work for MCI as the vice president of the Digital Information Services Company, built MCI Mail, and over a period of about 4 years, we got it into operation within 9 months of our initial work. It was really a wonderful, intense 9-month period. And then additions were made over a period of several years. But then as it became a more operational system with less development required, I decided to return to the research world and join my colleague, Robert Kahn, as he left ARPA and started a company called the Corporation for National Research Initiatives. And we spent 8 years together exploring applications of the Internet, digital libraries and knowledge robots and all kinds of other national information infrastructure concepts and applications for about 8 years.
It sounds as if you've had this obsession, I was going to use, but maybe passion is a greater word, or maybe a mix of both, that you've stuck with something throughout all those different jobs.
Maybe it's because I can't do more than one thing at a time, and so I tried to turn everything into one project. The fact is that I have been working on that kind of networking, or had been working on it since 1968 or so at UCLA, all the way through my years at Stanford and then the years at DARPA. And even after I left DARPA, I was still working on this in the application space. And by the time I left the research operation at the Corporation for National Research Initiatives, I was back at MCI putting them in the Internet business. And I stayed there until 2005 and then joined Google, which is also in the Internet business. So I've been fixated on Internet ever since 1968, which is, we can do the math now, is holy moly. Yeah. About 32 years. No, 42 years? 52 years. Can it really be 52 years?
Yes, it would. If it was 1970, yeah. It would be 50 plus 2 for the 68, 52.
Yeah, holy moly. That's a long time.
Time flies when you're having fun. And you've obviously been having fun. I mean, you look like somebody who loves their work.
I don't think that anyone should be forced to work on something they don't enjoy, but I've been very fortunate. Some people aren't. For me, every job I've ever had has always been a source of great fun, interest, challenge, and learning.
I was surprised to discover that you've been a visiting scientist at NASA JPL, the Jet Propulsion Laboratory. What did you do there?
Well, around 1998, I joined a team at JPL to start designing an interplanetary extension of the Internet. We had just seen the Pathfinder project land successfully on Mars in 1997. The previous successful landings were in 1976 with the 2 Viking landers, and then nothing worked for about 20 years. Things crashed and burned or missed the planet. But finally we got a success, and the Pathfinder landed. And so the team that I started working with was trying to figure out how could we build a more rich communications environment to support manned and robotic space exploration instead of just focusing on point-to-point radio links.
Which has this massive delay.
Well, that delay is going to have, we can't erase that. The speed of light and the distances between the planets is what determines what the latency is, what the delay is. We can't change that. On the other hand, we could have a richer communications environment with alternate paths to recover from various kinds of failure. And so we started designing this interplanetary internet. And I thought we could use the TCP/IP protocols to do this because it worked on Earth, so why wouldn't it work on Mars? And I'm sure it would work on Mars. The problem is between the planets, the distances are significant. They're literally astronomical. So even when we're closest together, Earth and Mars, we're 35 million miles apart, which means that a radio signal at the speed of light still takes 3.5 minutes to get to Mars. And, of course, another 3.5 minutes to come back. And when we're farthest apart in our orbits, it's 20 minutes one way and 40 minutes round-trip time. TCP/IP was not designed with a 40-minute round-trip time in mind. So we had to develop what we called a delay and disruption tolerant networking protocol suite, which we now call the bundle protocol, because bundle and packet sound about the same, but bundles are for interplanetary communication. So those protocols have now not only been designed, built, tested, but also standardized by the Consultative Committee on Space Data Systems, which is a UN agency made up of all the spacefaring nations, who are agreeing on what protocols should be in space in order to support manned and robotic space exploration. So we have ESA, and we have JAXA in Japan, we have NASA in the US, we have the Korean Space Agency, and others who are participating in the development and deployment of these interplanetary protocols.
Which would be incredibly useful, not necessarily planetary, but with the Artemis program and NASA returning to the moon, talks of a permanent settlement on there at some stage, possibly resource mining, that actually this is something that would be incredibly useful.
Well, that's right. And in 2024, we're expecting to launch the Gateway, which is an eccentric orbit spacecraft that goes close to the Earth and also close to the moon, kind of like a space elevator, because you jump on board the spacecraft when it's close to Earth, you ride it to the moon, then you take a shuttle down to the moon, you do what you have to do, you take a shuttle back up, and then ride the Gateway all the way around to Earth, and then shuttle back down to Earth again. So we're going to use the interplanetary protocols in that mission and other subsequent missions in preparation for the missions to Mars, which are still to come.
That's amazing. So no slowing down then. It's still work.
Why would I want to slow down? I mean, I have this 900-mile-an-hour theory. Once you get up to 900 miles an hour, don't slow down or stop, because you'll just fall over. So I just keep going.
You're very, I have to sort of describe the way you're dressed because it's incredibly dapper. It's a grey pinstriped suit with a matching waistcoat, a paisley burgundy tie, and a rather fetching, what looks like a red silk scarf in your top, in your breast pocket. Are you always this smartly dressed? I'd read that you were, but I thought, no, he can't always. Or maybe you do.
This is trademark. I've been wearing three-piece suits, pocket squares, and the whole bit for 44 years, and there's a simple explanation for all this. I was at Stanford doing the internet work when ARPA asked if I would come and run the program. And my wife, who was from Wichita, Kansas, announced that if we were going to Washington, D.C., I should be wearing three-piece suits. Now, she knew that I enjoyed being well-dressed anyway. I had not got the three-piece suit habit until she went and bought three-piece suits at Saks Fifth Avenue at Stanford Shopping Center in 1976. So we went across the country carrying my three-piece suits, and I went to work at ARPA, and one of the three suits that she had acquired used seersucker because she knew that it was going to be hot and humid during the summer months. So I ended up wearing those suits at ARPA. One day I was called to testify before one of the committees in the House in our Congress, and I was wearing the seersucker outfit. And I did my testimony, and I came back, and, nothing happened. We went on with our business. And then a few weeks later, the director of DARPA asked me to come to his office to discuss my testimony. And I was very fearful that I had messed up somehow, and he was about to fire me, and it was the end of my government career. So when I walked into his office, he had a letter from the committee chairman, and he said, well, the committee chairman says, thank you very much for Dr. Cerf's testimony. By the way, he's the best-dressed guy from DARPA we've ever seen. And I took that as positive feedback, and so I've been wearing three-piece suits ever since.
Absolutely right. It's funny you should say seersucker. I've not heard that word in a long time. It's an amazing material, and it is cool.
It is. It's very cool. I have two seersucker suits that I use for the summertime.
Now, you mentioned your wife, and I'd read that she had been deaf for a long period of time due to spinal meningitis. And, at the start of this podcast, you said, I didn't, and I was teasing you about, no, I have written it right, and you said, I didn't quite hear you. And you also have some loss of hearing. How did that happen?
Well, we don't know for sure, but I was 6 weeks premature in 1943, and back in those days, they didn't know what else to do but put me into an oxygen tent to make sure that my as yet immature lungs would get enough oxygen into the body. So the speculation is that it started as sensory neural loss, which has been continuous over time. So I lose about a dB a year. So at my age, I'm about 75 dB down. On the other hand, I've been wearing hearing aids ever since I was 13, and the hearing aids have gotten better even as my hearing has gotten worse.
I can't even notice
Well, they're
them.
just little hearing aids inside the ear. Now, in my wife's case, she lost her hearing when she was 3, and it was abrupt and complete. She became profoundly deaf in 1946, and she learned to lip read and spent about 50 years simply lip reading her way through life, which is amazing. She went to high school and elementary school and college and raised 2 sons without hearing anything. And then in 1996, at the age of 53, 50 years after she'd lost her hearing, she went to Johns Hopkins University in Baltimore, where she had a cochlear implant for the first time. She learned about the cochlear implant on the internet, which is sort of a nice irony. And that was an extremely successful operation. About 20 minutes after she went back there to Johns Hopkins to have the speech processor activated, she picked up the phone and called me. And we'd been married for 30 years and hadn't been able to use the phone. So that was a pretty dramatic moment for us. By the time I got home, I couldn't get her off the phone. She was, anybody who called, she wanted to talk to.
There's an immediate benefit of the internet is having knowledge at your fingertips. What would you say is its biggest potential? Because there's more, I assume.
Well, first of all, if you think about it as a facility for computer communication, you really have an endless potential array of applications. Again, it's simply a matter of figuring out how to program them. And so connecting computers together for various and sundry purposes is a dramatic aspect of internet, and it's gotten even more dramatic now that we can do it with radio links so that they don't have to be physically tied with wires. Now, Bob and I were doing mobile packet radio in the early and mid-1970s, in fact, and also packet satellite, which are both radio-based. That was deliberately done in order to find a way to use this technology for command and control, and we knew that it had to work in airplanes and ships at sea and mobile vehicles, and the original ARPANET was based on dedicated telephone circuits. So the radio aspect of internet has been with us literally from the beginning. What's more interesting in today's world is that mobiles are also part of the internet, and that was a fortuitous confluence. When the iPhone arrived in 2007, thanks to Apple and Steve Jobs, it immediately made these two technologies mutually reinforcing. The mobile phone, the smartphone, made the internet more accessible, and the internet made the smartphone more useful because it had access to all the applications on the internet. And of course, the smartphone itself has literally millions of applications have been written for it. And you can see how dependent people have become, you and I included, because there are many apps that we run all the time. And we use it for communication, we use it to look things up, we use it to play music, we use it to watch videos. Sometimes those are entertainment, sometimes it's to learn how to do something. So the benefits will continue to extend as we get more sensor systems in place for safety and security, for health monitoring, for environmental monitoring. In fact, eventually for self-driving cars, for smart cities, all of that is derivable out of the basic internet infrastructure. But perhaps the most important thing, and also the biggest challenge, is that this is a platform which is filled with vast quantities of information contributed by the world's inhabitants. Unfortunately, not all of them are capable of or choose to offer the best quality information. And so we have misinformation, some of it by accident, some of it deliberate, and disinformation, and wide ranges of utility in the content that we find on the net. And so if there's a challenge here, it's figuring out how to find good quality information on the net, how to inhibit bad behaviors and harmful behaviors using that internet infrastructure. So that occupies a great deal more of my time now than it did in the early days of internet when we were just trying to get it to work.
I mean, that's one of the big issues and conversations that's being had at the moment, isn't it? Is the ethics involved. I mean, where do you stand on that? Do you think it should be absolutely, totally free at the point of use, or that maybe it should have, as in, say, certain countries like China, more state control in terms of what you can and can't watch?
Several things occur to me. First of all, when Google indexes the World Wide Web, it's not trying to exercise value judgment during the indexing process. But when you do a search for something, one of the things that we try to do is to rank order the responses in order of utility in response to what we think you're looking for. We typically try to evaluate the websites, for example. There's a 168-page book which we use to train about 10,000 people to do manual evaluation of some of the websites. And then once we have got the sample set of websites that have been evaluated by those raters, then we use their evaluations in order to train a machine learning system so that we can run it against all the other millions or billions of pages.
So it's the equivalent of trusted sources, is that it?
Well, yes, although our definition of quality is what counts here, what makes a web page useful. If it's just a set of links, for example, we call that a link farm. We don't consider that to be useful, generally speaking. If it never changes its content, we don't consider that to be useful. If it's a useful website, it should be bringing new content to your attention. So the rank ordering of a response to a search is informed by the ranking or rating, I guess, that we have been able to apply to the web pages we've encountered based on the machine learning training that we've done.
Isn't that still subjective to what a certain group of people might decide is the right ranking? Because there are certain news organizations, for instance, that give more accurate news than others. But would they still have the same ranking?
Well, I want you to be very careful about how you ask that question, because the criteria by which we do the evaluation of a web page is not based on a subjective opinion about the content as much as it is the quality of the web page itself. Now, there are other reasons why we might end up ranking some websites and sources more highly than others. But one possibility is that more web pages point to that one, and it's an indication that it's viewed as more useful and more valuable than others. That's called the PageRank algorithm. That was the original mechanism by which we rank ordered pages, was called PageRank. Since that time, that was 20 years ago, we have several hundred different indicators that tell us something about quality, one of which is the source of the information. And as you say, what typically happens is that the people who do the training, create the training set, are more likely to train or to rate things like Financial Times higher than some other publication.
Than a tabloid, say.
So there is I would say an indirect recognition of quality sources based on the way in which these things are being rated. And in addition to which, the sites that are more frequently referenced often are indicative of the utility of the content. Now, the sad thing about all this is that once anybody knows about the specifics of these rating systems, they can try to game the system. So as an example, in the early days of the Google system, since the pages that were pointed to more were rated more highly, people would go build a bunch of web pages that point to a poor quality page in order to increase its apparent utility. So then we have to figure out in some more automated way whether that's what's going on, whether it's a bunch of useless pages that just happen to point to this destination. So we have this constant tussle. We alter the evaluation criteria and the results that come back. We see whether people click on the first, second, third, fourth, fifth response that we've given, and if everybody clicks on the second one instead of the first one, it tells us that maybe the first one is not a very good quality response, and that causes the system to be adjusted for that. So there's a variety of tools that allow us to respond, we hope, in the most useful way.
One issue that's very big at the moment is cybersecurity. Do you see this as a game of constant catch-up Are the cyber hackers always one step ahead, or do you feel that on the other side it's just in the same way of that people learn how to game the system, so you're the one who's trying to always be one step ahead?
Well, in the security space, it's a huge challenge because the hacker only has to find one hole to exploit, whereas the defender has to plug all the holes. So in that sense, you're always a bit behind of the hackers. The way to get ahead of that, of course, is to try to write software that doesn't have bugs, because if it doesn't have bugs, that probably means you can't exploit the system, unless, of course, it's a bad design in the first place. I mean, an example of a really bad design would be a device like a webcam that has either no access control at all or has a well-known username and password for control, in which case, in either of those two cases, somebody who is roaming around on the net looking for webcams could simply seize a bunch of them. And somebody did a few years ago and created a botnet that had about 500,000 devices in it. They were all webcams, and they caused the webcams, because there was no access control, to send their megabit per second streams to the same target, a company called Dyn Corporation. That's a 500 gigabit per second stream of data hitting that company's website and knocked it over. And that was a very dramatic demonstration of why you need to design systems that have access control built in from the get-go. So secure by design is a really important philosophy.
Now, you've won all sorts of awards throughout your career, and I like the fact that you'd crossed several presidents, because you'd received the US National Medal of Technology from President Clinton and the Presidential Medal of Freedom from George Bush, and appointed to the National Science Board, which is an honour in itself, I think, by President Obama. To me, it sort of shows the sort of cross-politics as well in terms of what you do.
Well, keep in mind that I moved to Washington in 1976, so I have worked with every administration, including Carter, all the way up to the present, and tried to be as apolitical as I could, although I will admit to you in my older years I have become somewhat more partisan.
What do you do to relax?
I am an inveterate reader. I enjoy reading history and biography. I'm a nut for science fiction, and I like things like Tolkien. In fact, I would read Tolkien repeatedly, once a year at least, because the language is so magnificent. And my wife and I enjoy watching films, especially if they're captioned, so that we can actually understand the dialogue. By good fortune, most everything is captioned these days, especially if it's a streaming video of some kind. So we're subscribers to things like Netflix and YouTube and Amazon Prime and all those other things.
I'm a bit of a Star Trek fan, so I was really impressed that you'd been technical advisor to a Gene Roddenberry production, Earth Final Conflict, which I'm embarrassed to say I've never actually seen. But how did you get involved in that?
This was a really interesting story. When I was at MCI, I was a senior VP for engineering, and the public relations team rented an auditorium in Los Angeles and sold tickets, and then told me that I was now to go and entertain people for 2 hours. They didn't tell me ahead of time. And so I was a little upset about that, and I said, well, I'm only going to do this if you can get me onto the sound stages at Paramount, where they were shooting all the Star Trek films and the television shows, thinking they'd never be able to do that, except one of the PR people used to be Tom Cruise's PR person, and she knew everybody and got me to Paramount. And so I spent a half a day running around in all the Star Trek sets. While I was there, I ran into Majel Roddenberry, Gene Roddenberry's wife, widow, and she started telling me about various television shows that she had discovered manuscripts for in Gene's office, which she hadn't gone into for 6 or 7 years. Finally, she found manuscripts for Earth, the Final Conflict, and Andromeda. So she started a production company called Lost Script Productions. They started shooting up in Toronto, and one of the other producers, who was with Majel at the time, said, well, why don't you be an advisor for the show? And I said, I'm happy to do that. And then they said, well, why don't you just come on the show and play one of the characters? So I became the president's chief of staff for Earth, the Final Conflict. And I only had one scene and one episode, But they were very sweet about it. I had my own trailer with a little star on it.
Great. That's great.
And it was the speaking part, which I understand is a big deal. So I had a great time.
Do you ever get inspiration from science fiction? Do you ever see someone think, yeah, actually, I could apply that, or I could take that?
Yes.
Or I could make that happen.
Well, frankly, yes. I mean, science fiction is usually about, especially nuts and bolts science fiction, which starts with known physics and then extrapolates. It really makes you think about what might be possible or what's in the way of doing something like that. So for me, science fiction and science fiction writers are great stimulants for thinking about what might be possible.
Now, the Queen Elizabeth Prize is well established now. And what are your memories of receiving the award and going to Buckingham Palace?
Well, first of all, I remember hearing the report on the radio, which was absolutely fantastic. All I could think of was, the engineers won. And I remember reading a book called Longitude, which is all about the Harrison family.
Davis Sobel.
And they were trying to build a ship's chronometer. There was a 10,000-pound prize way back, I guess, in the 1700s, which was a lot of money. But the Astronomer Royal of the time didn't think that the chronometer guy should win. He thought that the navigation ought to be done by the stars. And so he made it harder and harder for them to win the prize. It was 3 generations of the family worked on those things, and in the end, they did win. And so that was my first reaction. The engineers won. This time, the engineers won the Queen Elizabeth Prize. So that was really a wonderful feeling. And then coming here to London was wonderful because my wife, by that time, had a terrible case of Downton Abbey disease. And we'd already spent a month the year before in 2012 roaming around looking at 37 stately homes and manor houses, including Highclere, which is where
it was filmed. Yeah.
Where it was filmed. So then I'm thinking, well, we moved here for 6 months. We arrived in June, just as the Queen Elizabeth Prize ceremonies were undertaken, and so we met the Queen, 2 princesses of the realm, the Prime Minister, the Deputy Prime Minister, and I'm sitting here thinking, and a 200,000-pound prize out of the £1 million that I shared with my 4 colleagues, and I'm thinking, well, it's all downhill after that. Not the case, because a few weeks later I got an email asking whether my wife would like to come and spend the day on the Downton Abbey set with the cast and crew. And so from her point of view, the high point of our 6 months was Highclere.
That's brilliant, though. Do you spend much time in Silicon Valley? I can't imagine you with the guys with the hoodies and the women looking all trendy and what have you in your 3-piece suit.
I am a 19th century guy in a 21st century world. I wear my 3-piece suit when I'm out in Silicon Valley at Google, even though the Google dress code tends to be fairly relaxed. I do have a disguise, however. I have a baseball cap into which has been sewed a gray ponytail, and I wear that in order to distract from the fact that I'm still wearing a 3-piece suit.
Do you see the internet as a human right, effectively, that everyone on this planet should have access in the same way as, say, 100 years ago it would be to clean water and fresh air, clean air?
Even today, let alone 100 years ago, clean water and fresh air is something we all hope for. Human rights are very special things. It's clothing and shelter and food, things like that. I don't think of internet as a technology is a right that we can guarantee. However, the right to communicate, the right to get access to information, the right to share information is very fundamental to our society, and certainly to democratic societies. To the extent that the internet assists in that, enables that, it enables the right to communicate. If you had access to the internet and someone took that away, that would be a violation of your rights. The thing that disturbs me about asserting that internet is a human right or should be a human right is that it's just a technology, and eventually it will be replaced by something else. And so we wouldn't want the endowment of internet as a human right to become a kind of an odd confusion. When something better comes along, how should we react to the previous assertion that the internet was a human right? What is this new thing? So I would much prefer to focus on the fundamental right to communicate, to share information and get access to it, and to make sure that the technologies that enable that are available, regardless of what those technologies are.
And what would you say has been the driving force throughout your life and your interest? What has been that spark? Where do you think it's come from, or how would you define it?
I think this is the essence of engineering. It is the desire to design and build things that other people can use. There's nothing more satisfying to an engineer than to be given a problem to solve and to have the solution be useful to other people. Those are two really wonderful incentives for being an engineer.
It doesn't sound like you have any regrets, but I'm going to ask you anyway. Any regrets? Anything that you wish you'd done that perhaps somebody beat you to it?
Well, occasionally I wish I'd made a few $1 billion so I could give more money away. But the honest answer is that my career has gone along a path where that wasn't the best objective. The best objective was getting this technology out into the hands of people who could expand on it. So I was very happy to see my colleagues start companies, make internet happen, spread across the world. And to the extent that I helped to enable that, I found that extremely, and still find it very satisfying. So if there's any regrets, it's that this platform can be abused, and it is abused by people who don't mean you and me or others well. And that's why we still read Shakespeare 400 years after the plays were written, because he still illustrates in the most amazing way all the foibles of human behavior. And we see it reflected in the internet, and we have to try to do something about that.
Vint Cerf, thank you very much for joining me on the Queen Elizabeth Prize for Engineering's Create the Future podcast.
I'm happy to do this. It's an enjoyable conversation. What else is more fun than talking about yourself?
That's right. And you've got to give me that again when I asked you. Give me some level. What was that line again?
Oh, this is the Dominion network of the Canadian Broadcorping castration.
Not much I can say about that. Thank you.